Welcome to the normal distribution, part 2. What if we knew the area under the curve, we just didn't know the z-score? Then we would use INVnorm. We get there by going to the second key, vars, entering on 3 or INVnorm, and it asks us for our area. What did I say that area was? 0.4652. If this is a z-score, my mean is 0, my standard deviation is 1. If I'm on an old calculator, when I enter on the third choice, INVnorm, I'm back in the home screen, and I have to remember, I must tell it the area first, comma, the mean, comma, the standard deviation, in that order. And it will tell me that z-score was a negative 0.0873 if I round to the fourth decimal place. INVnorm assumes the area given is to the left of the z-score and goes out to negative infinity. It never, never, never assumes to the right. So what would we do if we knew that this area was 0.3765 and we needed to know the z-score? Well, if I've got 0.3765 to the right, I must have 1 minus 0.3765 to the left. That would be 0.6235 to the left. And I would do INVnorm. I would tell it my area was 0.6235. Tell it my mean and standard deviation. And I would find that that z-score was 0.3147. Notice 0.3765 and 0.3147, they're kind of in the same format, and they're easy to confuse. This is a z-score, a horizontal axis value, something on the number line. That guy is an area. Area under the curve, very different. As different as area and perimeter geometrically, very different. Don't confuse the two. If we had X random variable with a different mean and standard deviation. Let's say we had a mean of 150 and a standard deviation of 8. And I wanted to know what X value gave me an area to the right of 0.4279. First thing I have to do is find the area to the left, 1 minus 0.4279. That's 0.5721. Second thing I want to do is INVnorm my area to the left, my mean, my standard deviation. It tells me that value is 151.4538 if I rounded to the 4th decimal place. And that pretty much takes care of INVnorm. That should get you through Chapter 6 with the calculator.